All right, we are going to talk about equilibrium. We're going to do some problems on this worksheet. The problem is going to use this equation right here. It's up at the top of the worksheet. So we're going to be talking about these coefficients. You have to have a balanced equation eventually when we write our equation. And you will be taking note of the states of matter because that's going to matter when we're writing our equations as well. But for this first part of this worksheet, it's just asking how will different factors affect your reaction. So I've got a couple tricks for you. First of all, there is going to be a determination of whether or not you are increasing a factor or decreasing a factor. If you are decreasing a factor, you are going to draw an arrow toward a decrease. So T and D. See, both of those letters are consonants. So I say touchdown, TD. And you are going to draw an arrow away from an increase. So both of those letters are vowels. So I say AI, artificial intelligence. So the key words for me for memorizing what to do for an equilibrium expression is artificial intelligence and touchdown. Okay? So the first thing that you're going to do is you're going to determine what change they are making. Is it an increase? If so, you're going to put an I. Or if is it a decrease? Then you're going to put a D. Right over top of what they're telling you that you're increasing or decreasing. And then you're going to go to the place in the equation where the arrow is, indicating that your reaction is taking place. And above it, you're going to follow your TD AI directions, which is that you're going to go toward a decrease and away from an increase. And the side that's being favored, when I say this reaction is going to shift in whichever direction in favor, that means that side is going to be increasing. All right, so let's look at the equation. Here's the equation again. And I am looking at, right from this problem, I am reading question number 1 right now. It says, what effect would decreasing the temperature have on this reaction? Now, the temperature in this reaction is listed here in the form of your kilojoules. So this is where temperature is being looked at in the problem. And so I am going to decrease the temperature. So right over top of where temperature is, I'm going to put a D for decrease. Then I'm going to go to this middle arrow. And over top of that, I'm going to do one of two things. If I wrote a D like I did, I'm going to draw an arrow toward a decrease. And if I had written an I would draw an arrow away from the increase. So since this one was a D, I'm going to draw an arrow toward a decrease. All right? So toward a decrease. That means that this reaction is going to shift to the right. You have to know your left from your right here. This is the left side. This is the right side. And you should already know by this point, if you're talking about equilibrium, that these are reactants. And these are products. So when you look at your arrow, that means this reaction is going to shift to the right in favor of the products, which means my products are going to increase. I'm going to get more NH3, and my reactants, which are on the butt side of this arrow, would all be decreasing. Whichever way the arrow is pointing is the side of the reaction that is being favored, and therefore is the side where increases are going to occur. So on this particular worksheet, it says, what effect would decreasing the temperature have on the reaction? And my answer is going to shift to the right in favor of the products, which happens to be A. So what effect would increasing the temperature have on this reaction? So once again, I've got my reaction, and now instead it says increasing. So I'm going to go to where temperature is located. I am going to say increasing. Then I'm going to go to the arrow, and I'm going to do what I told you. If it is a decrease, it would have been toward the air. If it's a decrease, toward. If it's away of an increase. So it says increase, so I'm going to draw an arrow away from an increase. That means this reaction is going to shift to the left in favor of the reactants. That would mean I'm going to get more hydrogen gas and more nitrogen gas being produced because they are on the pokey end of this arrow. And the direction in which the reaction shifts indicates what's being increased. These things on this side would be decreased. So I would have a decrease in NH3. So that's how this problem works. So that one would be a shift to the left in favor of the reactants. Now we're going to do a couple of these, and then we're going to skip ahead to pressure. So let's just randomly pick. What effect would adding NH3 be? So I go to where NH3 is on my equation. I go to NH3 on my equation. What's adding mean? Adding means an increase. Then I go to the spot in the middle and I do what I'm supposed to be doing for an increase. That is away from an increase. So I draw my arrow going away from the I that I just put for increase. That means this reaction is going to shift to the left in favor of the reactants. Shift to the left in favor of the reactants. So that's my D choice. All right, so for most of those problems, knowing your AI is going to work out perfectly fine. However, on pressure, there is a slightly different. It says, what effect would decreasing the pressure and increasing the pressure have? And that depends on the reaction that you're looking at. So here I've got myself some things that I want to point out to you. Each one of these states of matter on this card are indicating that you're looking at gases. So all the gases will be included when you're tallying up the number of moles at play here. If you had, like this equation down here, where you had stuff that were liquid, or if you had stuff that were solid, solids and pure liquids don't get included in your calculations. But these are all gases. So I'm going to tally up how many moles of gas I have here. So how many moles of gas do I have on this side? I have 3, and there's an invisible 1 right here. If you don't see a number, it's automatically a 1. So on this side of the equation, I have 4. And on this side of the equation, I just have 2. Now that's important because for gases, you have to decide which way it's going to shift when they increase or decrease your pressure, which are questions number 9 and number 10 on this worksheet. First it said, what effect would decreasing the pressure have? So I think of pressure as somebody's yelling at me. And if somebody is yelling at me, then I want to go away from the yelling and I want to be more alone. So which side of the reaction is more alone? The 2. 2 is less than 4. So if they increase the pressure, this reaction is going to shift to the right in favor of the products. And if they decrease the pressure, which is what question number 9 says, what effect would decreasing the pressure have on this reaction? It's actually going to shift opposite. It's going to shift to the left in favor of the reactants. So I think of a low pressure situation is like I want to go to the party. That's going to be the bigger number. So high pressure, I want to be by myself. Low pressure, I'm happy to be with the most people, the bigger number. So you'll count up, and the only things you're counting up are the things that are gases. If there were other substances in your equation, you would not count them.